Hello friends. So in this lecture we are going to be studying some problems that will help us understand the concept of kinematics better. Now we have a problem presented before us on the screen, and the problem says a driver moving at 150 km per hour suddenly sees a child 70 meters ahead of him. Calculates the minimum acceleration required to stop the car. I repeat, a driver moving at 150 km per hour suddenly sees a child 70 meters ahead of him. Calculates the minimum acceleration now required to stop the car. Now, the first thing we must do in solving this problem is that we have to bring out the data we have been given. So the question says a driver is moving at 150 km per hour. So his initial velocity would be 150 kilometers per hour. 150 kilometers per hour. Now notice now that our distance now is given in meters, so we have to convert this velocity to our SI unit, right? And our SI unit will be meter per second. So since 1 kilometer is equal to 1000 meters, we're going to multiply this by 1000 because 1000 meters make 1 kilometer. So now in 1 hour there are 3600 seconds, so we're going to divide this by 3600. So in computing this, we have that our answer would be 41.7 meters per second. 41.7 meters per second. Now our final velocity now, it says now that the car has to be brought to a stop, so our final velocity will be 0. Final velocity would be 0 meters per second. 0 meter per second. Now the next data there says that he sees the child 70 meters ahead of him, so the distance now would be 70. Distance would be 70 meters. 70 meters. Distance would be 70 meters. Now we are required to calculate the acceleration we need to stop the car. So acceleration would be unknown. Acceleration will be unknown. Now let's move this upward a bit and let's solve the problem. Now we need a formula among the 3 formulas we were shown in the previous video, right? We need one of them that would contain both the initial velocity, the final velocity, distance, and acceleration, and that formula would be v square equal to u square plus 2as. V square equals to u square plus 2as. Now our v now from our data is 0, so that will be 0 square. Our u now is 41.7. That would be our u. Now we have to take the square of that plus 2as. Now our distance now is 70. So our distance is 70. Extend this down a bit. Now in computing this gives us 0, because 0 square gives us 0, right? Now 41.7 square in computing that gives us 1738.89. 1738.89. Now 2 times 70 now gives us 140. 140, and the a remains just the way it is, right? So I try to find a, which is our acceleration. So this right here, our 1738.89, we can move it over the equation sign, and we have that it becomes negative 1738.89. 178.89 will be equal to 140A. 140A. So we divide both sides by 140 to set our A free. To set our A free. Now, in order to find A, we are dividing both sides by 140. So this will be 140 here. This gives us, this goes, right? So our A now becomes, A would be, we are going to divide minus 1738.89 divided by 140, right? So this gives us minus 12.42 meter per second square. Why is the negative sign there? Because this was going to be a deceleration now. Going to be a deceleration, not really an acceleration per se, because we are trying to bring the car to a stop. So our acceleration would be a deceleration that brings the car to a stop.